Hello and welcome back. Today we're going to do some Newton's Law practice problems. So let's get into number 1. Let's say I have a wonderfully drawn car right here, and it's 1 ton, and it's moving to the right at 40 meters per second. How much force do I need to push on the car this way to keep it moving? And for now, let's pretend friction is not real. Well, I'll admit, this is a bit of a trick question, because the answer is none. Now, why is that? Due to Newton's first law, an object in motion will stay in motion unless a net force is acted upon it. And right now in the car, the only forces acting on it are the downward gravity force and the upward force of the road pushing back up on the car. So F net is 0. And so, since there's no net force on the car, it will continue its path of motion. It'll just cruise forever. Pushing on the car will only accelerate the car. And to keep the object in motion, you don't need to accelerate it. On to problem 2. Let's say I have a little kitty cat right here, and a litter box over here. Let's say that this cat is 5 kilograms. How much force do I need to push my cat with to accelerate it to a equals 10 meters per second squared? I need to get this cat to the litter box before it poops on my carpet. Here we can use Newton's second law. F net equals ma. And we know the mass, 5 kilograms. We know the acceleration, 10 meters per second squared. And we can solve for F net, which will be 50 newtons. So that means I need to push my cat with 50 newtons to accelerate it to 10 meters per second squared so that it gets to the litter box before pooping on my carpet. I will also say, never push a cat with 50 newtons of force. That is too much. This is just simply a silly physics question. On to problem 3. Let's say that me and Dwayne "The Rock" Johnson are playing tug of war. Now, since I'm so extremely strong, I'm obviously winning, since I'm pulling with a force of 10 newtons to the left. The rock is pulling with 5 newtons. And all that force, let's say, is centered around the center of the rope. If the mass of the center of the rope is 1 kilogram, what is the acceleration? We can use F equals ma one more time. F net equals ma. Well, F net is the sum of all forces. So since it's going to the left, I'm going to count my pulling force as negative 10 newtons. And the rock's pulling force is going to be positive 5 newtons. And that equals a mass of 1 kilogram times acceleration. Using this equation, we can find that the acceleration of the center of the rope is negative 5 meters per second squared. And that should make sense, since I am pulling with more force than the rock, so the center of the rope is going to accelerate towards me, because I am just that insanely strong. Alright, that's it for Newton's Laws practice problems. Good job and happy learning.